Welcome back to Physics 142. So we're in the middle of talking about combining resistors that are in parallel and in series. In the last video, we realized that when we have resistors that are in parallel, the formula that we use is this reciprocal formula, that 1 over the equivalent resistance is 1 over R1 plus 1 over R2 plus any other terms for additional resistors, whereas if we have resistors in series, we just add up all of the resistances, R1 plus R2, etc., etc. All right? And so an example I want to think about here is I've drawn 4 different circuits that all have 3 different resistors in them. All right, here in A, they're all in series. B, they're all parallel. C, we have this one's in series with each of these 2, which are in parallel with each other. And here we have a couple that are in series, and then those are in parallel with this resistor here. All right, and let's imagine that all of these resistors have the same resistance. What I'd like us to do is to think, well, could we rank these circuits in order of which one will have sort of lowest to highest, lowest amount of resistance to highest amount of resistance. All right, that's sort of going to be our task. So how are we going to go about doing this? Well, we need to think about then what's the equivalent resistance for each of these situations. So if we imagine that they all have some resistance R, right? All of these resistors have some amount of resistance R. Well, for the series one, we say, hey, we recognize these are all in series, so we add them up. That would give us a total resistance of 3R, right? For this circuit. All right, what about this circuit here? Well, here they're all in parallel, right? So we'd have 1 over R plus 1 over R plus 1 over R, which is 3 over R. And so then you invert it. So here the equivalent resistance would be R over 3, right? Or 1/3, and that makes sense, right? 1/3 of the current is going in each direction to each part, and so you end up with just 1/3 of the total resistance since it has 3 different paths to choose. All right, but what about, say example C here, all right? Well, for example C, we have 2 things in parallel and something in series, so we're going to have to break this down and sort of make simpler circuits, right? So what I'd like to do is, well, let's think about these 2 here, right? They're in parallel with each other. And if they're in parallel with each other, well, we know we could calculate this, 1 over the equivalent resistance of just these 2 in parallel. Well, that would be 1 over R plus 1 over R, which is 2 over R, and you flip that over, it gives you R over 2, right? So these 2 parts right here have an equivalent capacitance of R over 2, right? Half goes this way, half goes this way, right? But now this equivalent capacitor, R over 2, right? Req of this little part, right? Now we'd have a little series that would have a resistor R and another resistor R over 2, right? And if you have those in series, well, we combine them together. That's going to be 1.5 R, right? Or 3R over 2, right? Because we add an R plus half an R. All right, what about this circuit here? Well, this circuit here, now we have this sort of internal circuit. We need to combine these 2. They're sort of the internal part, right? The smaller chunk. And these are in series, so that will be a resistance of 2R, would be the equivalent resistance of these 2, right? And so now this would look like a circuit that has a 2R resistor and a 1R resistor, right? And so how do we combine those? Well, we'd have 1 over 2R plus 1 over R, all right? And so we need to get a common denominator. We'd multiply this by 2 over 2, right? And so that would give us 3 over 2R, right? Or when we flip that around, we would end up getting 2/3 of an R. All right, and so now we can rank these, right? And we see, all right, the smallest resistance here comes from B, that was R over 3, right? We have B. Then the second smallest resistance, well, that's what? That's the 2/3 R one, right? So that would be D. And then the third smallest, well, that's 1.5 Rs. That's going to be C, right? 1.5 R's, and then the most resistance is A. All right, so just even with 3 different arrangements of resistors, we can get very different amounts of resistance. And I think this is helpful, hopefully, in illustrating sort of what these combination formulas work like, all right? So in the next video, we're going to deal with, well, what if you have more complicated circuits yet, all right? Circuits where it's not so straightforward to just recognize, hey, these two are in series, I can combine them. How do we deal with those? So we'll move into that next.